In this example, we are going to continue trying to find the centroid of this composite volume. We are trying to find x bar in this example because the shape is symmetric when we're thinking about the z and y axis. So it's centered along the x-axis and it's symmetric in both z and y. So that z and y bar are both going to be equal to 0. So when finding our x bar, we have broken our shape into the cylinder and the cone. I'm going to start with the cylinder, shape 1. And I've drawn where our centroid is with that little blue dot right there. So we're going to start by writing what the volume of the cylinder would be, which would be the area of the face. So pi a squared times the height of that cylinder, b. The x bar of that cylinder is going to be located in the center of the cylinder. So x bar is going to be b divided by 2. And in this last column, we do the volume times x bar. So we're going to have pi a squared b squared divided by 2. We're now going to move on to our cone, but before we start the cone, we need to remember two things that we learned from our previous problem. So one of those things is that the volume of a cone, V, is going to be pi r squared h over 3. So I found that in the previous example, but I could have also found that by looking at a table in the book or Googling what the volume of a cone is. The centroid of our cone we found in our previous problem, let's call this x bar, is going to be 3 over 4h. And note, when we found that in our previous problem, that is from the point of the cone. So that means to our centroid, which I've drawn with that little blue dot, to the point of the cone is going to be 3/4 times the height of that cone, which is 2b. So that means this distance right here is going to be 1/4 times the height of the cone, 2b. So let's start filling in our table. We have the volume of our cone is going to be pi, the radius of the base, which is a squared. H is going to be 2b divided by 3. The centroid of our cone, we're talking in reference to our origin here. So first we have to go this distance from the origin, from here to the base of the cone. So that yellow line, the distance of that yellow line is b. So it's going to be b plus. So from the base of the cone to our centroid, it's going to be this distance right here, which we wrote down there is 1 over 4 times 2b. So if we add this up, we get 3b over 2 as our centroid. So we had to do b plus 1 over 4 times 2b because each x bar in this table needs to be taken with respect to the same point or the same origin. So it's b plus 1 divided by 4 times 2b. So when we multiply those two times each other, we have pi a squared b squared. I'm going to add one more row to my table here where I find the sum. So the sum of my volumes, if I add those up, is going to be 5 pi a squared b divided by 3. I'm also going to sum up my V x bar, because remember, x bar of a composite area is going to be the sum of VI x bar I divided by the sum of VI, or the total volume. So if I sum up my V x bars, it's going to be 3 pi a squared b squared divided by 2. So to calculate my x bar, I'm going to have 3 pi a squared b squared divided by 2 divided by 5 pi a squared b divided by 3. And a lot of things cancel out here, and I end up getting the x bar is equal to 9b divided by 10. So looking back at my original shape, that means from the origin to my centroid, I'm going to go 9b divided by 10. So 9/10 b. So almost to the base of the cone, but not all of the way. This wraps up our example of finding the centroid of a composite volume.